Yes, Varun, good evening. Hello. It's a very good, nice song and nice dance. இந்த அம்மன் கோயில்லாம் ஆத்தா வந்துருச்சுன்னு ஆடுவாங்க, அது மாதிரி இருக்கு. What song was that? Okay. But I enjoyed for 2 minutes. Good. And remember that as soon as you log in, I can hear your voice, whatever you chat, whatever you are talking to your mother, or whatever the mannerism you do, everything I can watch. So you have to be careful, right? Right. No problem. That's okay. Today we'll see the remaining part of this lesson. That is, we are talking about the defects of vision, isn't it? Defects of vision. We have seen about 3 different defects. As I have already mentioned, it is actually called refractive defects. It's because of the improper focus on the retina. That is because of the improper focus of the retina, or we can say the inability of the lens, eye lens, to form the image on the retina exactly. So that is why we say it is refractive defects, isn't it? So the first one is myopia, nearsightedness. The second one, hypermetropia or farsightedness. The third one is the presbyopia. So we have seen that that eye lens is also like a convex lens, isn't it? So these defects can also be corrected if you are wearing a suitable lenses, spherical lenses, isn't it? Let us see the first one. Myopia. That is nearsightedness. Myopia is nothing but nearsightedness. So here you have to remember, nearsightedness means you are able to see nearby objects. Okay. So a person with myopia can see near objects clearly, but cannot see the distant object. You can see the 2 figures given here, 2 diagrams given here. In the first photo, it is the normal vision. The person can see the object, all the object behind that far object or the closer object like balls or the boys, everything can be seen very clearly. But if we take the next diagram, you can see that this part alone is somewhat very clear. The very nearer portion of the ball also alone will be very clear. The other parts like distant object like this fence, the tree, everything is blurred, isn't it? So that shows that person cannot see the distant object distinctly. So a person who has got this myopia, the image may be looking like that only. It will be very difficult. So he has the far point nearer than infinity. What do you say that? Is it possible to have a point which is nearer than infinity? A person who has got this defect has the far point nearer than the infinity. Actually, we have seen that the far point and near point is 25 centimeters and far point is infinity, isn't it? So within this limit only a person can see the things very clearly, distinctly, isn't it? So for a person who has got this myopia, what happens? The far point is somewhat nearer than the infinity. Actually it should be nearer than infinity. That means it should be infinity, but little bit it is before that. That is what it means. Do you understand? It is before infinity. So if it is somewhat closer, we can say instead of saying that it is nearer than infinity, it is somewhat closer. Instead of saying infinite distance means which cannot be measured, isn't it? So, but it is shifted to somewhat nearer point. So that that kind of person may see clearly up to a distance only few meters. Only few meters. So that since infinite point is shifted to very closer point, we can see only object which are up to some few meters only, isn't it? So that kind of disease is called myopia. Here let us see very clearly. This diagram will help you to understand very clearly. See, in this myopic eye which has got the myopia, suppose if we take this object, this is the image, so there is object, okay? So distant object where they are playing golf, okay? So this image which is captured and which is refracted through this eye lens, the image is not actually forming on the retina. You can see that it is somewhat in front of the retina, not exactly on the retina itself. So that because of that, what happens, only if all the rays are focused on the retina only, the nerves will inform the brain that the object image is got clearly. Otherwise what will happen, it will be very difficult to transform the image, so you may be finding difficult to understand what kind of image it is. So that is how the myopic eye will produce the image in front of the retina. And why is it so? It is because the excessive curvature of the eye lens. That means the eye lens has got the excessive curvature or elongation of the eyeball. That means if the eyeball is somewhat little bit elongated, what will happen? This will also be little bit stretched up. So either the excessive curvature or the elongation of the eyeball, both may result in myopia. Okay, excessive curvature means, what do you understand by the term? The curvature, radius of curvature will be increased. So how can you increase the radius of curvature? How can you increase the radius of curvature? That means if the lens has little bit shrunken, if the eyeball, eye lens, if it is shrunken, that is, if the eyeball is pushing that little bit because of elongation, what will happen? This will become little bit thin. So the radius of curvature, it will become bigger than that, right? See, for example, look at that. Suppose this is the eye lens. Now this is pushing that little bit. So this curvature little bit will be like this. So what happens? You can see that the curvature is little bit increased. Now we can see the earlier one is this one. The earlier one was this one. Now when it is pushing, so the second one you can see that this is the second one, so that the radius of curvature is increased. So this is what we say excessive curvature. This may happen due to the fault in the eyeball, eye itself, lens itself, or due to this eyeball. When the eyeball is elongating, that will also result in the excessive curvature. So both will result in myopic defect. So that is why those people who have got myopia, what will they do? They will shrink their eye little bit, where they will find it difficult to see the images, right? So to make that image fall on the retina properly, what we have to do? We have to correct it by wearing a concave lens of suitable power. So what will happen? A concave lens with a suitable power will bring the image back on the retina, so that you tell me by guessing, can you tell me? If I tell the truth, you'll be laughing at me. Yeah. Tell me, just I'm asking you whether you are able to guess. You mean to say that far-sightedness, alright? Am I right? Yes or no? That is wrong. What you have told is wrong, because because this is only myopia. I am wearing this lens only for myopia. That is, there is some difficulty in viewing distant object. I can see things very clearly nearby. When it is somewhat far distance, like distant object like tree, something, there will be some little bit blurring of the image. So that I am wearing a glass of power just 0.5 only. It is minus actually. Minus 0.5. You know that why I am saying minus? Now can you tell me why minus? When I say that power is minus, what does it indicate? Come on. Exactly. As we have rightly pointed here, we are wearing a concave lens. Concave lens will make the image fall on the retina properly, because the image is formed a little bit before that. So I am wearing a concave lens suitably so that the image will be very clear and which is back on the retina. This is how we are correcting the defect. Right. But I have got another problem also. As you said, I have got hypermetropia also. Okay, so for some people, this kind, it is not a hypermetropia, I can say it is the other one, third one, presbyopia. This presbyopia is the third one. Due to aging, people may not be able to see the things which is very closer also. Isn't it? For such people, they have to wear a bifocal lens. That we will discuss, and I will tell you why it is not looking like a bifocal. The lens the glass which I am wearing is used for both purposes. Let us see, after discussing that, I will come to that point. Now let us go to the next one, hypermetropia. Hypermetropia. This hypermetropia is otherwise known as we have already discussed, the opposite of the previous one. That is nearsighted. Now here it is far-sightedness. So far-sightedness means that those people can see only the object which are at a distance, but they will be finding difficult to see the near object. See, here you can see in the picture, in the photo given here, this is a photo which is seen by a person who has got a hypermetropia. This hypermetropia, the near object is blurred one, you can see that. The distant object are very clear. This is how they will find it difficult to see the object which are very near distinctly. Okay. Actually, we know that the near point for least distance of distinct vision, isn't it? LDDV. It is 25 centimeter, isn't it? But for people who has got this hypermetropia, what will happen? They have to keep reading the materials beyond 25 centimeter from the eye for comfortable reading. That means they have to make it somewhat farther and see that. Because why? Because the light rays from the closer object are focused at a point behind the retina. You understand? Suppose if I keep an object like this, right? Suppose if I keep an object which is at 25 centimeter, the image of object will be formed behind the retina. So what I have to do, if I want to move the object a little bit away from 25 centimeter, then only I can keep the image on the retina exactly. Okay, that is how there is a shift in the near point for those persons. Due to that problem only, they are not able to see the nearby object very clearly, so they are called far-sighted. Okay, now see that image. You can see that by looking at the diagram, you can easily understand. Here you can see that the image is here, the object is here. When the object is seen by the eye, the image is falling far beyond the retina. So it is because the focal length of the eye is somewhat longer, because you can understand that if the lens is here, the focal, that is the principal focus should be here so that the image will be formed. But image is forming here means the focal length is somewhat longer than the normal one. Or the eyeball is somewhat becoming too small. Earlier one it was elongated, now it is shrunken, little bit small. When it is little bit small, what happens? What happens? The radius of curvature, it will be somewhat shrunken, so that is reduced. So when it is reduced, what happens? When it is reduced, the focal length will become somewhat longer. That is, it is focusing far beyond the retina. So they find it difficult to read the objects very clearly. So on the contrary to the previous one, we are going to use a convex lens. If you have got a power, plus power, then we say that they have got hypermetropia. So with a convex lens of suitable power, we can make that image fall exactly on the retina. So as you can see here, when the image is formed far beyond the retina, if you keep another lens here, another convex lens, so that the focal length is reduced. Here there is a note, you have to remember that. No. Here it is only plus. Presbyopia is, hypermetropia is only plus. Myopia is minus. Okay. The last one is due to different category that we will discuss. Now here one point you have to note down here. This may be useful for you to apply this when you are answering multiple choice question. Here, the focal length is somewhat larger, we said here, isn't it? Suppose you take for example, the focal length is say 20 centimeters. When you are using another lens, convex lens, you see that what happens to the focal length? It is reducing or increasing? Tell me. So this is another point you have to note on. Sometimes multiple choice, they may ask you by giving one convex lens, if the focal length is this much, they are adding one more convex lens with this focal length. Do you think that the resulting focal length will be more than that or less than that? Sometimes they may give in the multiple choice. Clearly you can understand by using this diagram that the focal length will definitely be less than the previous one. If you are using one single convex lens, when you are using double convex lens, the second one will be less than the previous one. So that point you have to note down. Okay, right. The next one is the presbyopia. This is the one which is because of aging. When people cross around 40, okay, 35 to 40, and generally after 40, the power of accommodation, the power of accommodation, that is the ability of the iris, to adjust the pupa, that is the lens, accordingly to reduce the little bit curvature to see the things clearly, it becomes somewhat decreasing. The power of accommodation is slowly decreasing as we become older. So for most of the people, generally the near point gradually will be receding away. That means the second one, what is that? The hypermetropia. Generally that will be, it will be receding away, means moving, shifting far away, so that the image will be formed behind the retina. So they may find it difficult to see the object comfortably without the lens. So that is what we call as presbyopia. Okay. Usually it is not occurring for young people, it is only for older people, that when they cross 40 only. So what is the reason for that? There are two reasons they give. One is the gradual weakening of ciliary muscle. Already we have discussed that the ciliary muscles are only helpful in contracting or elongating the eyeball, isn't it? Pupil, isn't it? Or the second one reason may be diminishing flexibility of the eye lens. Both are there, because the ciliary muscles are only reason for making the lens, as we have discussed about the ice fruit, nungu pati sonole adu mari. So either the lens may be losing their flexibility, they cannot little bit shrunk or elongate due to aging, or the muscles will become weaker. As usually we know that even the whole body muscles, they will become weaker as we grow older and older. Especially when the sensitive muscles like ciliary muscles, they will definitely be weakening. So due to this weakening of ciliary muscles or the loss of flexibility of the lens, both may be the reason for this presbyopia, because they may shrink their eyes to, they may find it difficult to see object. Even if they strain their eyes also, they may not be able to see. But the young people, if they little bit strain, they can see the object very clearly, even in a bright light or dim light. But these older people, if they cross 40 years, they may find it difficult as they are not able to adjust their eye lens easily. So such kind of people, they want a bifocal length, which is what we call as the farsightedness and the nearsight, because for both the cases the eye lens is not able to adjust, isn't it? So they have to wear a lens which has got both the lenses, concave and convex. You can see here they have got two lenses here, yeah, bifocal. This one is for reading the near objects, which is nothing but called a myopia, and the next lens is called a hypermetropia. For both it is combined. But nowadays you cannot see this kind of lenses. People, they know they want to keep their image without spoiling. If they wear this kind of lenses, people will say that, oh, this fellow has become older, he has crossed 40. So they don't want to lose their image. What they do, they are wearing a lens called a progressive lens. What is that progressive lens? In that progressive lens, yes, in that progressive lens, the lines will not be seen. Though it is a bifocal, the manufacturer will make the lens in such a way that both will fade away, right? The near that is the concave and convex, both the lens will fade away and they will mix together, so that they may not be able to see a line. It will be like a plain glass. So generally they can say, it is only for headache I am wearing. This is not for eye defect. Thereby they can make themselves safe by losing their image. So that is called a progressive lens. But the problem with the progressive lens is that you cannot suddenly see any object. Suppose if you are riding a bike, you are not advised to wear that progressive lens, because this on both the sides, in both the sides, in the curved path, the shifting will be very difficult, right? Here, but here it is very easy. The people who are wearing this kind of lens, when they are reading, they will keep their lenses somewhat on the nose. You would have seen the specs will be kept on the nose. So when people are looking at that, they will see through this eye, distant object. They can read through this part by using this part alone when they are reading a book. So by thereby they are keeping the specs on the nose, isn't it? That is on the tip of the nose. But in the progressive lens, they cannot have the shift very easily, because on the sideways when they look, somewhat will be glaring. So they may find it difficult. That is why they have to get accustomed to that. They have to keep on wearing for a long time, so that they will get used to that. So that is the latest advantage. That is a development in the bifocal length. And usually, as we have already told, the upper portion, which is used for correcting the hypermetropia, the lower part is for myopia, that facilitates the near vision. But this wearing of glasses, whether it is bifocal or progressive lens, all these have become out of fashion. Okay, what happens? They just don't want to even say that I have got a defect, eye defect. They want to eliminate that bad image also. They simply wear a contact lens, which can be fit even on the eyeball itself, lens itself, so that nobody can understand whether they have got a eye defect. So that is called a refractive defects, can be corrected by using a contact lenses. Contact means it is in contact with the eye lens, our eye lens. So by just keeping that on that contact, that is eye lens, all the effects can be corrected. You can see here the same effect only here also made, but what is the difference is that lens is outside the eye, but this lens is just on the eye. That is the only difference. So that there are possibilities that you can give coloring also for these lenses, different colors like a cat eye or honey brown or green, any color can be given for this so that your eyes will become very beautiful. But for other external glasses it is not possible. So thereby the modern world is preferring this kind of contact lenses, yes, colored contact lenses, right. So this is what all about the defects of vision. So do you know how to keep your eyes very safe from all these defects? What is the remedy for that? Yes? No. It is only nowadays you can see that in olden days people were not wearing. Suppose if you take some 100 years back, you would have seen hardly very few people used to wear this kind of glasses. Two things are there. One, you may think that people were not aware of that because that facility was not available at the time. The second reason is most of the people were very healthy. They were eating very healthy food like a carrot or a green leafy vegetables, and the food habits, good food habits, and even the food which they were cultivating was also very pure, unpolluted. They were all using only what do you call it as bio manure, organic manure we say, like a cow dung, isn't it? Sawdust, vegetable waste, everything they were using without any medicine, that without any fertilizer, artificial fertilizers. So that is why they were able to keep their body, muscles, everything very healthy. But nowadays it is very, very difficult to maintain because even if you are eating a good amount of vegetables, fruits, everything, even the vegetables are also polluted with artificial fertilizers. So that way it's very difficult. Even it is said that as we grow, even if you say, for example, if you take after 50 years, people even with people of 10-year-old will start wearing glasses. Nowadays you have seen even the newborn baby is wearing specs. I have seen 1-year-old, 2-year-old children are wearing specs. It's very difficult for them to maintain that also. So it is only right from the young stage they have to have good food habits. By that way only we can avoid. Otherwise it's very difficult. And also being a vegetarian is very, very important one, isn't it? So though they say that non-vegetarian food gives a lot of vitamins, nutrients, everything available necessary for food, that is not actually true. Though they take that, the other factors will definitely reduce their immune system so that they weaken their body very quickly. You would have seen that those who are having body built strongly, like Mr. World or Mr. Universe, whoever you say, or whoever, I am a Paka Brahmin man. How can you ask me this question? Okay. So those people who build their body, at that point of time it may be looking good, very beautiful. But as they grow older, they may lose their muscle power also. It will get the strength, the rigid power will also be lost. So very soon they will become weak. If you compare a person who is taking vegetarian food and non-vegetarian food, for example, you can take animals also. Which animal, when you compare an elephant or even a deer or compare with a tiger or a lion, if they are running for a long distance, after chasing, you know that the lion or tiger will become very tired. Even after running for a long distance also, the deer or elephant will never become tired. They will always be remaining energetic. That is the greatest advantage of being a vegetarian. I could see that even in Chennai or in some other foreign countries also, people are slowly becoming a vegetarian because, and also it is very good to eat raw food. instead of cooking the food, the people advise that if you take food items raw, like green leafy vegetable, fruits, everything, that will give you a lot of immune power. That because when you are cooking any food, most of the nutrients are lost actually. Even the rice food which you cook, the rice, after generally in olden days the red rice was preferred. Nowadays we don't even see that kind of rice. We use only white rice. This white rice is almost like oil cake, you can say. It has got nothing. Even that oil cake has got some amount of nutrients, but this rice is nothing but waste, because everything we wash by polishing, we are losing the nutrients, vitamins. After that we are washing that and cook that, and after cooking we take the cooked water also. What the thing we are eating is of no use at all. So if we start eating like this kind of food item, definitely it will not be beneficial. So that is why we have to take more amount of fruits actually. Whatever season, in whichever season, what kind of fruit is available, we should never hesitate to take. Instead of drinking cool drinks or burger, pizza, we can spend more amount on buying fruits and eat vegetables, fruits, everything. That will definitely give you a lot of power than the others. So that is the secret of maintaining a good health for your eyes. Okay, let us come to the next point. The refraction of light through a prism. Refraction of light through a prism. It's a nice and interesting phenomenon when it comes to a prism. Here generally we say at a triangular prism. A triangular prism will be looking like that. Right? You can see that it is a block of wood actually. Triangular prism made up of wood. Okay, it has got two triangular faces. As you can see here, this is a triangular face, and the bottom there will be another triangular face. Two triangular faces and three rectangular lateral surfaces. This is the rectangle. You can see one rectangle, another one, and another one. So three rectangle faces, lateral faces, and two triangular faces. And these surfaces, they are inclined to each other. You can see that all the three are inclined to each other. If you take these two, they are inclined. If these two, inclined. Okay, all the faces are inclined to each other. And the angle between these two inclined faces, that is called the angle of prism. Can you tell me, for a triangular prism, what could be the angle of a prism? For this triangular prism, what could be the angle? Say, for example, take this one. Yeah? You don't need to think, it's a triangle. You know the angle, some of the angles in a triangle is that difficult to answer? Yeah, everything is 60 actually. Yeah, this is what we see. Generally, the prism will be equilateral. What we use in the lab, generally it will be equilateral triangle. So this is what we call as angle of the prism, which is indicated by letter capital A. Okay, usually we indicate this by capital A, what is called the angle of the prism. Because remember that when you are taking science group in 12th standard, we are going to use this prism to find out the angle and the refractive index of this glass, material of the glass. There will be one practical. To find out that, we will be using a special instrument called a spectrometer. Spectrum means, you know that, we are going to measure that, so it is a spectrometer. So, now understand that this is a triangular prism. As I said, it is also available in the scientific shops, laboratory, instrument shops, where you can buy that and do the experiment and enjoy. Okay? Hope that you will start buying one by one. Otherwise, I will give you the address from Chennai. Okay, you can just call them and send the items by courier. You can straight away get to your house, so that you can start practicing so many experiments at house and you can become a young scientist. Let us see the next one. Here, there is an activity. which will help you to understand the prism, that is how the prism is going to refract the rays, okay, and also how to find out the angle of the prism and angle of deviation, everything you can see here. And this is done by a girl in a lab, okay, which will understand. Just watch carefully and then you can ask me if you got any doubt on this video, okay, right.
Aim of the experiment is to determine the refractive index of prism by IDCOR method. The apparatus required are the drawing board, a white paper sheet, glass prism, 4 hairpins, fixing pins, pencil and meter scale. The working procedure is: first fix the white paper sheet on the drawing board using fixing pins. For measuring angle of prism, draw 2 parallel lines. Put the prism on the 2 parallel lines such that the base should be on above the 2 parallel lines. Then draw the outlines of the prism. Fix 2 hairpins, one of the 2 parallel lines. Fix another 2 pins such that the image of the previous 2 pins and these 2 pins will appear to lie on the same line. Then remove the prism and remove the hairpins. Join the 2 points. One of the parallel is called as the incident ray and the new line is called as the emergent ray. The same procedure is applied for the other parallel line. Then there will be 2 emergent rays. Join 2 emergent rays and measure the angle between 2 emergent rays, and that angle is the angle of prism. This procedure was repeated for 3 times. Then working procedure for measurement of angle of minimum deviation of the prism. For that, first draw a straight line on the middle of the paper covering the whole page. Then put the base of the prism on the straight line. Then draw the outline of the prism. Then draw a inclined straight line to the base of the prism, making an angle of 30 degrees by using protractor. Then put the prism on the base. Put 2 hairpins on the inclined straight line, and that will be the incident ray.
Yes. Tell me. Tell me, Varun.
Take precautions that the 2 pins are perfectly vertical to the plane. See the image of the 2 pins. Fix another 2 pins on the opposite side of the prism by seeing that the image of the previous 2 pins and the feet of the two pins appear to lie on a straight line. Then remove the prism. Join the 2 points. This will be the emergent ray. Then join the incident ray and the emergent ray. The angle between the incident ray and the emergent ray will be the angle of deviation. Extend the incident ray and the emergent ray. The angle formed between incident ray and the emergent ray is the angle of deviation. This procedure is repeated for 3 times.
So you would have seen that here, this is one of the activities which is done not only for your class but also for 12th standard. Okay, you can see that this is what it simply means. That suppose if you keep a triangular prism like this and you have drawn a line here which is called the incident ray, and we have fixed 2 pins here. Okay, both the pins, okay, that should be seen on the other refracting surface. So this is one surface, the other surface here. So they will get deviated and they are coming out as emergent ray. Okay, the angle between the emergent ray and the normal, that is called the angle of refraction. But the angle between the incident ray and the emergent ray, that angle is called the angle of deviation. That is what given here, angle of deviation. Okay. This can be easily done when if you got a prism, even at your house also you can try. Just you have to have the basic needs. It is shown in the video also. Of course, the language was somewhat difficult because that girl is from North India, so the pronunciation may be somewhat different. You know how they are pronouncing English. Okay, they will bite that words. Prism, they will say, isn't it? It is actually prism, but the way they pronounce is different. But the concept is the same. Okay, so by using a pins, you can just put the pin on the other side. By looking at the other 2 pins, they should lie on the same line. In such a way, if you put and remove the prism and join the lines, you can easily plot and get the angle of deviation for different angle of incidence. By changing the angle of incidence 30, 45, 50, you can keep on getting the angle of deviation. This is how the activity goes on. Okay, so this is the diagram here. You can say this is the position of 2 pins. So this is considered as the incident ray, and these are the positions of the other 2 pins. This is considered as the refracted ray. Okay, refracted or the emergent ray we can say, because prism will refract actually. So the ray which is coming out is called the refracted ray or the emergent ray which is coming out. And this angle between the normal to the surface and this angle, it is called angle of emergence, emergent. Okay, angle of incidence and angle of emergence. Okay, so angle between the incident ray and the normal, this is called angle of incidence. Okay, and similarly, this is called the angle of refraction. You can say how much it is deviated. Okay, from the actual position. This is the angle after once it goes inside that, it is getting deviated. So that is why we say it is refracted. Okay, understand? So this is the diagram which shows about the refraction which is taking place inside a prism. And the next concept, very interesting and beautiful concept, which is created by the Almighty, which is called a dispersion. dispersion of white light by a glass prism. Here you can see, I would have seen the spectacular colors of a rainbow. Usually this is given by actually the sunlight, the white light of the sun, which is giving the different colors, 7 colors, as we can see that as a rainbow. How is it possible to give this 7 color? Because we are able to see only 1 color from the sun, but all of a sudden we are able to see 7 colors on the sky. Why is it and how is it coming out? So let us learn how is it coming out. Now here the prism actually has the property of splitting the incident white light into a band of 7 colors. Right? This band of 7 colors is what we call a spectrum. We have to remember that. The word spectrum is nothing but a band of 7 colors. This is called a spectrum. Okay. Now, you can see that how the band of colors, they appear at the two ends. Here you can see the white light is only coming out when it is refracting through the triangular prism. They get split into different colors. And also you can see the sequence of color also. VIBGYOR, isn't it? This is what we call as VIBGYOR. VIBGYOR. This VIBGYOR is actually, you can note down one important thing, that from the base, right? From the base, the violet is very closer, right? From the base, it is very closer. Deviating, if you just extend this line, you can see that which is deviated more. Violet is deviated more. Isn't it? So red is deviated lesser. So this way, all the colors are deviating towards the base. Why? Because it is entering, the light is entering from rarer medium to the denser medium. This is denser medium, this is rarer medium. Okay. On the other hand, if it is on the other case, it will be deviating away from the base. It will be moving this way. Okay. Right. And also you have to remember the 7 colors. Actually, the acronym will help you to remember. The VIBGYOR will help you to remember the sequence of colors. Violet, indigo, blue, green, yellow, orange and red. VIBGYOR. Okay, this word is very familiar and famous, and everybody knows that. VIBGYOR is the band of 7 colors, is called a spectrum of colors. And this spectrum, spectrum, you may not be able to see all the colors separately. Though in the spectrum also, you cannot see like a line. It is something like a combination of different colors. Okay, but something is making, you can see that it is something like a one single band, but something is there which makes somewhat distinct from each color. You are not able to see a band exactly like red, like violet, like blue, like green. You cannot see the colors separately, but as a band only are able to see, isn't it? So this kind of splitting of white light into its composite color or constituent colors, component colors we can say, this is called a dispersion. This is another technical word in physics, another phenomenon we can say. What is dispersion means? The splitting of light, composite light into its component colors. Composite light is nothing but white light. Composite is the light which has got 7 colors inside. So splitting of composite light into its component colors is called a dispersion. Or simply you can say splitting of white light into 7 colors, component colors, is called a dispersion. This is called a dispersion. So the dispersion is possible only if there is a prism. Without prism it is not possible. Okay. So how do we, why do we get these colors? Right. This is because as we see that this white light is consisting of 7 colors inside. When they are entering from rarer medium to denser medium, since it has got 7 colors, all these 7 colors will travel with a different speed, isn't it? So that means they will be deviating through different angles. They will bend because refraction is taking place. Refraction is nothing but the deviation of light from its path, isn't it? But the color which we see is called a dispersion. Here both are taking place. The dispersion is because of the refraction. So the refracted ray, what happens? The bending, the different colors are bending with a different angle, because each color is a different color, light wave. So this wave will be traveling with a different speed in the different medium. So when all the colors are traveling the same medium, here from this medium to this medium, because of the speed of this color, light, it is deviated to different angle, and that is why when they come out of that, the angle is reflected, so that we are able to see a band of 7 colors. Right, here you can see that, as we have already told, that red is least deviated. When you take the path of light here, red is least deviated and violet is most deviated. This is also one of the important multiple choice question. Out of 7 colors in VIBGYOR, which one of the color is deviated most, they may ask. You have to remember that prism with base at the bottom, violet color is here. From here VIBGYOR, so violet is deviated more. Exactly. It is not. You have to remember that we talk about refractive index only for the material of the prism, not for the color, not for the light. Okay. The material only has got a refractive index. We cannot say that color has got refractive index. Remember, we compare the air and the glass. The glass has got refractive index, the air has got refractive index. We can compare these two, not the color. Here we are talking about only the deviation or the refraction, or how it is deviated. The light, this light is deviated more, blue light is deviated more, red color is deviated less. By this way only we can compare. Okay, right. Now this great scientist Isaac Newton was the first person to produce this spectrum using a glass prism. He only used this glass prism to produce the spectrum of sunlight, because sunlight has got white light. Using the prism he was able to produce, and he, on seeing that prism is splitting the white light into 7 colors, he started exploring more. He kept one more prism after that, thinking that from 7 colors it may be multiplied to 14 colors or something like 15 colors. He was curious to know whether many more colors are coming out of the prism. But on the contrary to this experiment, he could not get any other color. Up to 7 colors only he was able to get. Then he started rotating the prism. He keep on rotating the prism. So at one stage you could see that no color is coming out of the prism. Where? Yes, because when the prism is upside down, this prism is splitting the colors into 7 colors. Again, from this rarer medium to denser medium, what happens? Again the light is refracted. So all the 7 colors are combined into white color. So thereby what we call as recombination of colors. We call this as recombination, combining all the 7 colors into again white light. So we call it as recombination of or recombining of colors. So this is how you got a only white spot. And also he did another interesting experiment where you can also try that. You can take a small cardboard, right? This small cardboard, and divide this cardboard into 7 colors. That is 7 sectors, we can say 1, 2, 3, 4, 5, 6, 7. Equally, it should be equally divided 7 sectors, and each sector should be given one color. Out of this VIBGYOR, you give this color as VIBGYOR, VIBGYOR. If you give all the 7 colors and then put a small hole here and just keep that in a pin and start rotating that, right? Once you rotate, after few seconds you can see that the colors will not be seen. The cardboard will look like white only. Instead of doing such a very difficult experiment, he did a simple experiment to show that the combination of 7 colors. 7 colors can be made into a white color. This is called the Newton wheel. Newton wheel. Such an interesting experiment you can also try. Okay. So this is what the idea which is done by Sir Isaac Newton. He showed that all the 7 colors which can be made into a single color, white color, by using another prism which is kept upside down. Okay. And this observation only was the initiation for Sir Isaac Newton to understand the idea that sunlight is also made up of 7 colors. thereby he was able to give the reason for the rainbow, right? So the remaining part, how the rainbow is caused, all those things we can see in the next class. If you got any questions, you can ask me now. Tell me. It's a very funny question because you remember that this focal length of a plane mirror. Do you think that can measure the focal length of a mirror, that is plane mirror? Because the focal length is always, it is a constant for a mirror, because it is not possible to measure the yes, either it should be a concave or it should be a convex, then only we can have the radius of curvature and we can find out the focal length. But here, since it is not a curved one, we cannot find out the focal length. It is a plane one. The word itself says it is a plane mirror. So we cannot measure the focal length. We can say, yes, we can say infinity. Any other? Tell me. Okay. What's that? What's that? Tell me again. Tell me again. See, if you are, say for example, if you are talking about just look at that. See, this is the plane mirror. Okay, this is another plane mirror. If they are kept parallel to each other, you are talking about two plane mirrors, isn't it? I can't get your question clearly. Tell me again. Hello. What is the question again? Come out. Hello. Repeat the question, man. What happened? Hello? What happened? Got stuck? Huh? Repeat the question. Hmm. Usually, if two plane mirrors are kept parallel to each other, right? If any image is falling on a plane mirror at 90 degree, then only they will fall in the same way. Isn't it? Yes or no? So they will become parallel to each other, the incident ray and parallel, because if you take a plane mirror, at whatever angle it is falling, since it is reflecting back, the angle will be same. Both the angle will be same for any ray. If only they are parallel to each other, both the mirrors are parallel to each other, you can say that the incident ray and parallel ray will be parallel to each other. Isn't it? So it should be 90 degree normal. Normal. Should be normal. Okay. We'll see the remaining part in the next class. Yeah.